Hello everyone. This is just to show off my my intelligent motor drivers for DC motors with quadratic encoders. I've designed the board so that it all runs off I2C, so we've got the ground power clock and data wires coming in, and I've designed them actually so that they can actually go end to end, so that will plug into another board and then so on and so on. For this demonstration I'm running it off an Arduino 33 Internet of Things, but so it's 3.3 volts. The system on the drivers is the chip I'm using is 3.3 volts, but I have a feeling that you can actually connect a 5 volt I2C bus to it. If we look at the data sheet, if I find it, data sheet. This is the chip I'm using. It's the STM8S103F2, and we can see that the SCL and SDA. I've got this T next to it. Excuse me, I just need to move the chair. Which means that these are true open drain. So if we look, I've marked the pages, so if we look at the data for that, we can see that the V in on our pins, on the true open drain pins, which there's only 2 of, which is on the I2C bus, it says here 6.5 volts, and the rest is within 0.3 of your VSS. So as we're running on 3.3 volts, we can only put 3.3 volts on all the rest of the pins. But I think that on the I2C bus you may be able to put the 5 volt on there. So what did I save that one there for? Yeah, so there, yeah, so we've got the from the VDD, so we've got 3 to 5.5 volts there, so it's only on them 2 pins though, so we can't put anything on the others. So hopefully it will work with the 5 volt system. I haven't tried it yet, but hopefully that will we can put the 5 volt on these 2 pins, but the rest of it is, the power needs to be 3.3 volts, so we can only put 3.3 volts in on these. Can I zoom in? Get it to go in focus. Come on, focus. Tell you what, let me just get one of these boards. Maybe I can get that to go in focus. There you go. There we go. Yeah. So there's only 3.3 volt on the power line, but the SDA and the SCL may be able to take 5. But the rest, the board itself is 3.3 volts. And I've got 5 of them, so to show. So I've got 1. That's number 5. This is number 4. That's number 1. And then I've got a number 2 over here. Let me just move the. Oh well, what I'll do from the Nano, we've just got the I2C coming out. That's all that comes from the microcontroller. This is just an extra power supply. It's just adding an extra 3 volts, which is a bit temperamental. And then we go across to my bus, which I made a little I2C bus, so all the I2C is connected onto that bus into one thing. and I've also got a 24 volt rail here as well. So this is on my 24 volt for all the motor power. So the motor power comes in with 24 volts, comes in on this pin, and then we have the motor out on the other one, and then these four wires, these go to the quadratic encoder. I've made room for the putting physical stops on as well on these. But this demonstration I'm just going to show it with 5 motors. I'm going to move the camera, so just bear with me. Just get it. Oh, there we go. This is another project I'm going to be working on. So let's just lock it off there. So I've got the one motor at the bottom. It's one of me. Well, if I turn it around, you can see that it's one of my. They're all these motors are the same. They're all 4 different motors. This one's slightly different because it has. If I turn it around, you can see these cables. It has. It'll come to me in a minute. It has slip ring in the middle of it, so I can pass cables through from the outside up into this through this one, and as it rotates, the wires won't get tangled up because it's got a slip ring down below underneath. I don't want to move it too much because I've only got these connected up temporarily, but we can see that that's my number 1, which is the base one, 2 and 3, and then we've got 4 and 5. 4 and 5, shall I say. So I've put little tags on the motors so you can see them turn round. I'll do the base first. So the idea is that, like I said, we've only got the I2C wires coming from the microcontroller, and we can control all 5 motors now from the I2C. So what I've done is I've connected up my my serial monitor to the Arduino, and what I can do is I can send commands from this serial monitor to the Arduino, and then the Arduino will then talk to the relevant motor driver, and it will turn that particular motor driver. To swap between devices or motor drivers, we just put a D command in, so I can put a D1, and that is now telling the Arduino that we want to talk to driver 1. So because I've changed the I2C address on each of them, and I've just made them 1, 2, 3, 4 and 5. So we're on that, and we can send the next command to find out its data, and we can see that the I2C address is 1. I've set the speed for all of them at 400, and we can change all these settings just through the I2C, and it will remember them because it goes into the flash memory. So if I want to move the base, I can send a geo, which will, currently it's set at sensor. I can send it in the G1 command, which will send it in one direction. The G2 will send it whatever number of ticks in the other direction. So if I do the first one, G1 command, send that at full speed, you can see it sends it to. I'm not going to spin it all the way around because I can't drag all these these cables around with it. So eventually I'll have this. This is part of another project I'm working on. It's up to you to guess what it is, but we can send it in the other direction, and then it'll move the same. And if I want to bring it back to 0 again, I can bring it back to 0. I think actually if I set it at that slight angle, if I set it at that slight angle, you can see this. So that was our driver 1, and then I've got driver 2 here, 3, 4 and 5. So if we just change to I can just add the command on to the end, so I can call it D5, and it will actually send this, instead of sending it to D1, which we were on at the moment, it will now send it to D5, which should turn this end wheel the same amount. So if I send that, you can see it sends it to D5, and then if I send it in the other direction, and if I wanted to send it to 4, which is this one, and then 3, I'll do 3 and then 2. So if we do the same for all, so if we just change that, I can send it to the other motor. And if I change it to 3, we'll send it to the other one. And if I send it to 2, we'll send the other one. Now, you don't have to just do one at a time. The thing is, we're sending it to the I2C bus. You can actually send it to all of them. Well, you can do one after the other. If you actually programmed it in your microcontroller, the time it takes is just the time it takes to go down the I2C bus. But for me, I've got to type it out. So what I'll do is we're on D2 at the moment, which is the first one. And it won't change from D2 until we actually tell it to go to another driver. So what I'll do is I'll just send the F8 on the 2, so you should be able to see that spinning. So we can leave that end one spinning, and hopefully you'll see the tag come round if it hasn't dropped off. There it is, there we go. So you can leave that one going, and what I'll do is I'll do it on the same on 5, so I'll send 5 going as well. So let's just send that also to D5. And so we've got the 2 end ones going, and while they're going, see, I've just sent the forwards command to them. What I'll do is I'll send the reverse to this one. So what I'll do is I'll just send that one going in the other direction. So they're all sort of, so that's in sync. What I can do is if I stop this one, send an O command, I'll just wait till it comes down to here. There, and then what I'll do is I'll set that going again. Oops, when the other one's in about the same place, and then they should be in sync there, like so. You can do that, and then while they're happening, I can be sending the other ones, say this command. I'm not going to spin these round because there's a little trap, but what I can do is if I send that one, and let's go 3000. Oh, actually, that was the wrong one. Where was I? So we were still on this, weren't we? So catch up. Yeah, there we go. Get that one going. I must remember next time. So this one we want to be on D2. So if I go, no I don't, I want to be on D3. So if I go D3, oh that one's already there, so let's go 2000. Let's if that's 2, 4, yeah, let's go about 6 on that one. We can move that round to about 6 there, look, and I'll do the same with 4. That's going in the opposite direction, so what we'll do is we'll bring that one round to the front, and I'll change that and bring that round to the front. So you can see from this demonstration, I hope my voice is coming over the noise of all the motors turning. And then what I'll do now is if I'll go put all that to 0, and then we'll start with number 2, and we'll bring them all back to 0 again. So what I'll do is I'll send that, and then we'll do 3 and send that, and then we'll do 4, send that, and do 5 and send that. So they should all come back to 0 eventually. The 2 middle ones have come straight back, but obviously the end ones need to go a bit further. Like I say, this one was on for quite a long time, so it's going to be quite a while for it to go back to 0. Because they will actually count up to, if I go back, if we take a look at the my code. Right, let's move that so we can still see that moving. What I've done is the number of ticks that we can have, I've made up like a 24-bit plus number, and so we can actually have 16 million ticks that we'll remember. I have actually, I'll leave it going for a while, because I'm sure that oh yeah, actually what we can do is, I'll bring that back, while it's going we can actually send the X command. So we're on number 2, so I'll just check. Well, we're on D2, and then we'll send the X command, and we can actually see our position. Oh, so there we're at 82,000 so far, so it should be counting down. So if we send again now, we can actually see we're at 78,000. Well, it's going to take quite a while actually, because I did set that going early on, but we can keep checking, just keep sending. 68, so you can see how long it's going to take. I'm not going to wait that long, I'm just going to send a stop command. So what we can do is we can do a GO command, and we can just stop that where it is, and then we could check and see what position we've stopped at by sending the X again, and we can see we stopped at 37. We've got a C command, so I can set that, and I can send that, and what that does is 0 it. So if we send the X again and have a look now, we're at 0. Is it this one? Yeah. So there's a lot of commands I've put for actually setting the positions of everything. What we can have is a station and such things, so that we can actually set a point that if we were to put some stops on. So I have put some options here to put some physical stops on. So we could put a stop on these. So it won't go beyond them points. And also there's a stop for a station, so once it triggers a station, it then sets a position that you set in the commands. So you can actually set a station command, and you can set all these numbers using these C commands. We have an S command which does the speed, so we can alter the speed. Oh, let's just show you that as well. So we'll do this end one. So we'll just make sure we're on D5, and then I'll just set it going forward at 800, and then if I turn it down to 2, you can see it goes on a slow speed. I wonder if I can get it down to 1. There, so a really slow speed. This speed number is 0 to 1000. It's just a pulse width modulation, and it's 1000 is 100%, and obviously 0 0. And then so if I put 1000 in, it'll go at the full speed. And all these commands can be sent to whichever motor you want, and then we can put an FO, and it'll stop as well. Like, there's many. So if we're using the forward, so if we're using a forward command, we can have the forward stop, and then we can have F1 forward at the current speed, or we can have F1 and also have an S value which sets it at a certain speed. So you can, so if we have the F1, let's put that back, F1, and say 500, S500, we can send that, and it goes at 500. And what I can do is I can put the R100, so let's put the R command, which will be the reverse, but let's change it from this current speed to 1000, which is the full. So when I click send, it will actually send it in the other direction at full speed. I don't know if you really noticed that, but obviously if we do 500, you don't need to, if it's actually running, you only need to put a speed in, so we can speed it back up again. And then, so that's our forward and reverse, and then, well, we've seen the go-to, which is basically, it goes to a preset value, and you can add a speed as well if you want. So that's most of the commands. Let's just stop that. You don't always have to put the 0 in, because the buffer, when I send the command, the buffer actually is full of noughts, so everything after that character is noughts, so it'll see it as a 0. So let's just move it back again. So we'll go to D1, which is our tabletop rotation, and we'll just send that back to 0. Oh, very well. Not that one. I forgot to send it, I think. Did I send it? Clear that. Right, I've sent it this time. Right, let's try that again. There we go. Just have to remember and make sure that you're talking to the right motor. But obviously when you're putting it into your code for whatever project you're building, it'll be a different matter. So I hope that was of some interest. So I think it's a very handy little driver that we can use for DC motors, and if you've got an encoder on, you can set the position and everything. And it the pulse width modulation does really work down to the low figures. I found with a lot of drivers you can't go below half speed, so I don't know what that is with the purchase ones, but this one you can actually go down to, if there's no load on it, you can actually go down to a low speed, you know, into the sort of like 10% of your pulse width modulation. And what else I was going to say? You know, my memory. Oh yes, the voltage. Yes. So basically, I reckon from, you know, sort of like the 5 volt range up to 30 volts. Well, that's what the MOSFETs are rated at. But I mean, if you look at the size of them, can you see? I don't know if you can see them, but they're really tiny little things, how they can get 30 volts and at 3 amps as well, although the ampage is limited by the tracks they have on the PCB. So because I wanted it small, some of the tracks are quite low, and I reckon you'll be all right for 1 amp with these small tiny tracks are not the motor part. I've made the motor tracks as thick as I can wherever possible, so I reckon it's good for 1 amp at least, at about 24 volts anyway. So so it's got a good range. Well, I hope sorry about waffling on a bit there, but hopefully you can see that you can control more than one mode. Oh yeah, and the I2C address on these boards go from 1 to 26. 1 to 126. So in theory you can have 126 motors controlled by one microcontroller. I hope you found it of interest, and I'm going to do a full Instructable once I get round to it. I'll publish it on Instructables, or I might even do it on the I can't remember the other one. Hold on. Yeah, I might do it on Hacksters as well. I don't know. See how it goes. Okay, well, hope you enjoyed it.